Hi everyone, welcome back to Array series. Hope you are doing good. This is Mahesh. In this video, we will look into Leetcode problem number 189, which is rotate array. So let us look into the statement of this particular problem where there is a given integer array nums and you need to rotate the array to the right by k steps. Okay, where k is a non-negative number. So basically k will be a positive integer number and they have given few examples if you see, and they have also mentioned the constraints. The length of the nums array lies between 1 and 10 raised to 5. Okay, and the number in the array, any number in the array will lie between minus 2 raised to 31 to 2 raised to 31 minus 1. Okay, and k can be anywhere between 0 and 10 raised to 5. Okay, let us switch to our editor and let us try to understand this problem. So this problem is pretty much straightforward. So we need to rotate this particular array by given k, which states how many steps we need to rotate this particular array. So since in this example k is 3, so what we need to do, we need to rotate this entire array by 3 steps. So it means first I will rotate 7. I mean this part will move towards right and this should come to the beginning. So my first step will be, step 1 will be 7, 1, 2, 3, 4, 5 and 6. This is one step. Next, second step would be 6, 7. So this time this will come at the beginning. That's why it starts from 6, 7, 1, 2, 3, 4 and 5. Next, step 3. So now again 5 will come at the beginning. So 5, 6, 7, 1, 2, 3, 4. So after rotating this particular array by 3 steps, we will get this particular output. So we need to return this output. So this is basically what is expected out of this problem. Okay, with that they have also mentioned the constraints. The length of the array lies between 0 and 10 raised to 5. What does this mean? I have already mentioned in one of the earlier videos, if the length lies between 0 or 1 and 10 raised to 3, then even if we solve a particular problem in O of n square, it will accept the solution. If it is between 10 raised to 3 and 10 raised to 5, then it will accept n log n solution. But if it is greater than 10 raised to 5, then we need order of n solution. Otherwise, it will give us TLE. So with that, maybe you can pause for a second and you can think for any possible solution and you can come back. Okay, so now let us try to understand what is the idea or the intuition behind this problem. What interviewer will be looking by giving this problem to you. So basically he wants us to solve this particular problem in O of n time complexity and O of 1 space complexity. That will be his expectation. So with that, let us try to solve this problem in a very naive way. So basically that's a brute force solution for this problem. So if you look into this particular problem, what is the bare minimum solution that you can think of initially? So now what I will do, I will try to take this array and I will rotate this by 3 times, something like this. This is first rotation, second rotation, third rotation. Okay, let us implement the same way. So for that to happen, so first we need to implement how to rotate this array by 1 position. So let us do that. So now what I will do, I will take the array again, 1, 2, 3, 4, 5, 6, 7. Okay, now what I want to do, I want to rotate 6 here, 5 here, 4 here, 3 here, 2 here, 1 here, and then 7 back to this place. So for that, what I will do, I will take a variable, the last number, and I'll keep it in this particular variable. Next, after that, I will start from this last position and I will iterate till this position and I'll keep moving the element towards right. So what I will do, so this is my index. So here 0, 1, 2, 3, 4, 5 and 6. So initially I'll start with index 6. Now what I will do, I will move the element at, so maybe I will draw like this. Okay, so this is 0, 1, 2, 3, 4, 5, 6. Now what I will do, these are the numbers. Now what I will do, I will start from index 6. Then what I will do, I will move this number here. So I will remove this, I'll move. Next what I will do, I'll come to the next index, which is 5, which is this one. Then I'll move this number here. So I will remove 6 and I'll move 5. Okay. Next I will come to fourth index, that is here. Then I'll move 4 here. I'll remove, I'll move. Next I will go to third index, then I'll move its previous number. So I'll remove this and I'll move. Next I'll go to second index, I'll move the element at first index. So I'll remove this, I'll move. Then I will come to my first index, then I will remove this and I'll move. Now I will stop. Then whatever number we have with this last variable, I'll simply copy that on 0th index. So basically this is 7. So this is how we do one position movement in the array. So let us try to write a pseudocode for that. So now last equal to, so before that n equal to nums dot length. Okay, last equal to nums of n minus 1. Okay, then I will use for I equal to n minus 1, I greater than 0. It is not greater than or equal to 0. I will stop when I reach the 0th index. So I greater than 0, then I minus minus. Now what I will do, I will simply say nums of I equal to nums of I minus 1. This is basically the previous number. So we will do this movement. This will copy all the numbers from n minus 1 to 1 index. Then at the end, I will say nums of 0 equal to last. Okay, with this way, we will do one step shift towards right for the given array. So if you see, we do n shifts, right? That's why the time complexity is of order n, but space complexity is of order 1 because we are not using anything extra here. So this is for moving one position towards right, but that is not the problem here. So what problem states, we need to move k steps. K can be 1, k can be 2, k can be 3, or k can be n. Okay, so if that is the case, now what I will do, I will call this as shift by one position, then it accepts nums array. Okay, this is one method. So I'll remove this part. This is one method. Now what I will do, I will use another for loop for I equal to 0, I less than k, I plus plus. Then what I will do, I will call this particular method shift by one position. So shift by one position, and I will pass my nums array. So basically it will mimic these 3 steps, okay, for k equal to 3. So once it will, for whenever I is 0, that time it will do first shift. Whenever I is 1, here whenever I is 1, it will do the second shift. Whenever I is 2, it will do the third shift, and whenever I reaches 3, it will stop. So basically it did 3 movements, correct, right? So this way we will implement the brute force solution. So now if you see, this one will take order of n time complexity. This runs for k times. So what is the total time complexity for this problem? It will be order of n into k, order of n into k. But space complexity is still big O of 1 because it is not using anything extra. Okay, so this is extreme naive. Interviewer will not be happy with this particular solution because it takes big O of n into k time complexity. So how to improve this? So now let us take the example again, and these are the indexes. Okay, now k will be 3. What happens after the shift? After the shifts, it will be 5, 6, 7, 1, 2, 3, 4. This is after k shifts. Now what we will do, let us take another array. Okay, now if you take the original array, our one is at 0th index. So again I'll loop from 0 only, but this one I will shift it by 3 position and then I'll place it in the resultant array. So if that is the case, then in the resultant array, I need to store it at 0, 1, 2, 3, 4, 5, 6. I need to store it at 3. Correct, right? So I starts at 0, but I will store copy it at 0 plus k, which is 0 plus 3 equal to 3. So I will do that. I'll keep that here. Next, I'll move to next index, the next number. Then I'll place it at the next index. So 2 will come and sit here. Next, 3 will come and sit at 5th index. Next, 4 will come and sit at 6th index. Now if you see, I have my 5. So if that is the case, where it should go? Now again it should start from 0. So it means we will have to use the modulo operator to again start from the 0th index. Next 5 I will place it here. Next 6 I'll place it here. Next 7 I'll place it here and I'll stop. So this way, this is our result array and we can return this array. Okay, let us try to write the pseudocode for that. So now what I will do, I will take a result array equal to array of size n. Okay, so you can, in Java, you can say something like this. So in JavaScript, you can do this way. So anyhow, it's a pseudocode. So result will be an array of size n. Okay, now what I will do, I will use my for loop for I equal to 0, I less than n, I plus plus. Now what I did, in the resultant array, I added my k. So I'll do that. So result of I plus k, but I should not do I plus k only because after it reaches the 6 value, it will overflow. So for that, what I need to do, I need to modulo by n. This way, whenever this index crosses 6, automatically it will start from 0. Then I will copy the element from nums of I. Okay. So this way, what we will do, we will copy the elements from nums array to results array, and then finally I will return the result. Okay. Now if you see the time complexity, it is again big O of n because we are iterating only once here. So that's why it is big O of n, and we are simply copying it to another array. But space complexity is of order n here. Why? Because we are using this extra array which we are using it to store the elements. That's why it is of order n. Okay, so this way we can improve the previous solution to order n time complexity. Let us try to execute this and see. Okay, so now what I will do, I will take constant n equal to nums dot length. Okay, now I will take a result array, new array of length n. Okay, after this I will use for loop, let I equal to 0, I less than n, I plus plus. What I will do, I will say my result of I plus my k modulo n is equal to nums of I. Okay, this way it will copy all the numbers into the result array. Then I will return my result. Let me run this. It is giving wrong because we are trying to return the result, but they are expecting us to modify the values in place. So what I will do, I will simply loop one more time, or let I will copy this. Okay, then I will say, I will have to remove this, nums of I equal to result of I. This way it will replace the values in the original array. Now we don't need to return anything, that's why simply I will run this. If you see, it is accepted. I will submit it. The solution got submitted successfully. Okay, let's switch to editor. Now if you see here, we are using extra space. We are using extra space to rotate this array by k position. But with this, interviewer will not be happy. So we will need to boil down this to somewhere order of 1 space complexity. So how to do that? Let us take the array again, 1, 2, 3, 4, 5, 6 and 7. What will be our shifted array? It will be 5, 6, 7, then 1, 2, 3, 4. Now let us see, this part is this one and the remaining part is this one. Okay, somehow. Now what I will do, I will simply rotate this particular array. Rotate in the sense I will reverse, rather I will reverse this particular array. So if that is the case, what will be the reverse? It will be 7, 6, 5, 4, 3, 2, 1. Okay, I have reversed my entire array. Reverse entire array. So we can do this in place. I will explain you, how to do that in place later. But for now, you see, we are reversing this entire array. Now what I will do, since our k value is 3, I will reverse the initial k values. Basically 3, right? So it means from 0 to 2 index, that is k minus 1 index, what I will do, I will again reverse the values. If you see, it becomes 5, 6, 7. Okay, after this, the remaining values, again I will reverse them separately. So it means they will be 1, 2, 3, 4. If you see, we got whatever the rotation we wanted. So what I did, basically, I reversed the entire array once, then reverse reverse array from 0 to k minus 1 index, then again reverse separately from k minus 1 to n minus 1. We are following 3 simple steps. So with this we will get our rotated array. So now we will also understand, so this will be valid only if we do it in place. So it means we will have to reverse this particular array in place, not using extra space. So how to do that? Assume I have this small array 1, 2, 3. So if I want to reverse this array in place, then I need to use two-pointer technique. Two pointers technique. So in the previous video, one of the videos where I have introduced you to this two pointers technique, there I have mentioned whenever we will be having such space complexity order of n, whenever we want it to be more optimal, like somewhere order of 1, that time we prefer to use two pointer technique, right? So that is what comes into rescue here. So now what I will do, I will take a left pointer, I will take a right pointer, maybe I will increase one more number. This is my right pointer, this is my left pointer, this is my right pointer. Now what I will do, I will swap them. So I will swap them, then I'll increment my left here, then I'll decrement my left here. Okay, then again I'll swap them, then I am done. I got my reversed array. So this reversing is done in place, right? So that's where our two pointers technique come to help. Okay, so with this, let us try to write the pseudocode for this. So first what I will do, I will write a logic for reverse. I will send my array, maybe something like this array, or you can take nums only. So nums, then left pointer and right pointer, or start and end also you can take, it's of your choice. Then what I will do, while I will take a while loop, while left is less than right, until unless left is right less than right, what I will do, I will swap nums of left comma nums of right. Okay, then this is done in place, so I don't need to return anything. I'll simply close this. So you must be knowing swapping, right? So we will take a temp variable, then it will be nums of left. Okay, then nums of left equal to nums of right, then nums of right equal to temp. So you can use this logic to swap. Now with that we have written reverse method. Now what we will do, we will actually do this particular logic. Okay, so I will simply call reverse nums is our nums input, then my left will be 0, my right will be n minus 1. This particular statement will reverse us the whole array, correct, right? Next, after this, what I will do, I will again reverse, I will pass nums from 0 to k minus 1. Okay, next again I will call reverse, then I will say nums of k to n minus 1, the remaining numbers. So this will give us the reversed array in place, and we don't need to return anything. So with this, if you want to see the time complexity, what is the time complexity? So basically we are doing the swapping for this entire array one time. Then again we will swap half array. Maybe, I mean, you assume k will be exactly n by 2, and that's assumption, but it won't be the case. And remaining elements are reversed in the next call. So time complexity will be somewhere order n, and space complexity is order 1 because we are not using anything extra here. Here everything is done in place. So this is the beauty of two-pointer technique. So it will boil down our space complexity from order of n to order of 1. Okay, hope that is clear. So let us try to execute this and see. I will comment this part. So now let us write one more method, constant reverse equal to, it takes nums array and left index and right index. Then what it does, while left is less than right, it will swap the numbers, correct, right? So I will take const temp equal to nums of left, then nums of left will be assigned with nums of right, then nums of right will be assigned with temp value. Okay, after this I will simply increment my left pointer and decrement my right pointer. Okay, this will reverse us the values in the array from left to right pointer in line. Now what I will do, I will call, but before calling, one thing what we need to consider here, this k value can exceed the n value. If that is the case, it is again a repeated rotation, right? So if it is more than n, if the k value is more than n, we can simply subtract that n value. So what I will do, I will check if my k value is greater than n, then I will simply reassign this with k modulo n. This will make sure, I mean, it will remove the unnecessary rotations. Next, after this, I will call reverse. I will pass nums array and start will be 0, end will be n minus 1. Then again I will call reverse. I will pass nums array. Now I will pass 0 to k minus 1. Then I will duplicate the line. Now I will call from k to n minus 1. Okay, so this will rotate the array by k steps in line. So let me run this. I will remove this content for readability. So now my solution got accepted. I will submit it. If you see, the solution got submitted successfully. So this is the most optimal solution for this particular rotation problem. Hope this explanation you like it. If that is the case, please consider subscribing to my channel, and also like this video, share this with your friends, and also if at all you have any queries or any problems that you want me to solve in future, you can add that as a comment in the video. Thanks for watching the video.